Mitsubishi Electric has been designing and manufacturing commercial hot water heat pumps since 1970. We were one of the first manufacturers in Japan to utilize heat pump technology to supply hot water. Our hot water heat pumps are used in Japan, Europe, Oceania, Asia, and many other regions. As a pioneer in heat pump technology, we would continue to lead the industry. This video introduces our state-of-the-art heat pump technology. First of all, let us explain how heat pumps work. Heat pumps absorb heat energy from the atmosphere and transfer this energy into refrigerant. The heat energy absorbed from the atmosphere is compressed by a compressor, becoming a high-temperature, high-pressure gas refrigerant. Then the gas exchanges heat with incoming water through a heat exchanger. The water heated by the heat exchange is stored in a tank and used when hot water supply. In this system, the refrigeration cycle is completed inside the unit. Therefore, the refrigerant does not go to the tank or to the place where you use hot water. As you can see, it is highly efficient and able to output about 3 to 4 times the input electrical energy. What are the benefits of heat pumps? Firstly, since heat pumps heat water with electricity, you can contribute to a significant reduction in CO2 emissions. Secondly, heat pumps are safe and clean thanks to the non-combustion system which does not discharge toxic substances. Additionally, heat pumps output 3 to 4 times the input electrical energy, so their high efficiency allows you to reduce running costs. Lastly, due to its electric system, fuel equipment is not necessary, which results in easy installation and maintenance. With a system controller, centralized control is also available, so you can remotely monitor each unit and adjust the desired temperature and amount of water. Now let's look at the benefits of a heat pump more deeply compared to gas boilers and electric water heaters. To begin with, heat pumps' high energy efficiency is the most significant point. As for energy efficiency, gas boilers and electric water heaters are less efficient. Gas boilers are operated according to the load, resulting in frequent starts, stops and increased fuel consumption. Also, since electric water heaters use a heater, it inefficiently consumes electricity. On the other hand, thanks to the heat pump system, we can achieve an output of about 3 to 4 times the input electrical energy. With the highly efficient heat pump system, you can significantly save the running costs. Furthermore, heat pumps are much safer than gas boilers since heat pumps utilize electricity instead of gas combustion. Heat pumps with no combustion system achieve less emission of CO2, contributing to eco-friendliness. Here is our product lineup of hot water heat pumps. We have 2 series, one is CAHV and another is QAHV. The biggest difference is the available outlet hot water temperature. While CAHV can achieve 70 degrees Celsius with R454C refrigerant, QAHV can achieve 90 degrees Celsius with R744 refrigerant. Let us briefly explain our 2 types of hot water heat pumps. On the left is CAHV, a circulating hot water heat pump. It provides high performance in keeping and raising the temperature of hot water. It is mostly adopted in accommodations, swimming pools, and so on, where heat retention and temperature rise are required for large public baths and outdoor baths. Not only that, it is utilized for space and floor heating when connected to radiators on site. On the right is QAHV, a once-through hot water heat pump. It demonstrates high performance when heating water quickly, so it is often adopted in welfare facilities and hospitals, where people use showers and water faucets. Thanks to these features, we can offer suitable products to each facility depending on the purpose. Now let's look at each product more deeply. In the next part, we will introduce you advantages of CAHV, such as low GWP refrigerant R454C, new compressor, wide temperature range, highly efficient control, and low maintenance and design flexibility. Our CAHV adopts the low global warming potential refrigerant R454C. Thanks to this eco-friendly refrigerant, we contribute to the significant reduction of CO2 emissions. In Europe, the F-gas regulation is going to be implemented to prevent global warming and unwanted climate changes. The current target is to reduce the total amount of F-gases by about 80% across Europe by 2030 compared to 2015. Now we offer more environmentally friendly hot water heat pumps that use the low GWP refrigerant R454C. The GWP of R454C is 148, and this is approximately 91% lower than the R407C refrigerant that is used in the conventional model. One of the most important key technologies is our new compressor compatible with R454C refrigerant. Improved with these three features, it is now an essential component to achieve higher efficiency and capacity in low ambient temperature. Let's go through one by one. One of the crucial aspects is the new spiral structure. The new spiral design has brought the significant effect of a 15% increase in the extrusion volume from the discharge section compared to the conventional model. The low density of R454C refrigerant requires an increased amount of refrigerant from the discharge section. Our new compressor uses a new material for the fixed spiral section, which enables the tooth to be thinner while maintaining their strength. Secondly, Mitsubishi Electric's unique technology, the flash injection circuit, is adopted. This is a special circuit used in the Zubaden series for cold climates and ensures high-temperature water even at low ambient temperatures. When the outdoor temperature is low, the discharge temperature of the compressor will rise due to the refrigerant property. This causes energy inefficiency and malfunction of the compressor. However, since this flash injection circuit creates two-phase refrigerant and controls the increase of the discharge temperature, the optimal amount of refrigerant can be provided to the system via the compressor. Besides the two significant improvements, we successfully expanded the inverter frequency control lower limit. This expanded lower limit control helps minimize thermo on-off frequency during low load operations, such as in intermediate seasons, and improves energy efficiency. Next, let us show you the wide temperature range. Since our new model has a wider temperature range compared to the conventional model, it can suit various installation environments with different outside temperatures. Firstly, the lower outdoor temperature limit for outlet water of 70 degrees Celsius has been expanded from -10 to -20 degrees Celsius. This improvement allows you effectively eliminate Legionella bacteria. Secondly, the operating temperature range has also been improved. The lower outdoor temperature limit is extended to -25 degrees Celsius, and the upper outdoor temperature limit is extended to 43 degrees Celsius. CAHV is also equipped with a highly efficient control system. According to the load, the main unit can control the number of operation units. For example, when the temperature sensor perceives temperature variation, the main unit sends a signal to the subunits. Since the main unit calculates how many units should go into operation with how much capacity, they can achieve energy saving and highly efficient operation. Next, low maintenance is one of the points that we are proud of besides the strengths we mentioned so far. When two or more units are in the system, the unit runs alternately, ensuring an optimum product lifecycle for both component units. Since they run alternately to equalize the cumulative operation hours, that leads to the long life of the units. Lastly, design flexibility contributes to the CAHV's advantages. The number of outdoor units can be adjusted from 1 to 16 according to the tank storage capacity. Therefore, depending on the loads on site, it can flexibly meet the design requirements. Now let's move on to QAHV. In the next part, we will introduce you advantages of QAHV, such as natural refrigerant R744, high efficiency, operation in low ambient temperature, and outlet water of 90 degrees Celsius. First of all, QAHV adopts R744, an environment-friendly natural refrigerant, which does not destroy the ozone layer and has significantly low global warming potential. With this CO2 refrigerant, QAHV can contribute to the reduction of CO2 emissions. Moreover, compared to other common refrigerants, such as R410A, R32, and R454C, R744 is more eco-friendly and safer as it is classified as an A1 refrigerant. Since A1 refrigerant is defined as a non-flammability and low toxicity, R744 is much more reliable. Secondly, QAHV can achieve high energy saving with our unique technology. QAHV utilizes a twisted and spiral gas cooler, which is Mitsubishi Electric's state-of-the-art technology. Thanks to its efficient piping design, it maximizes heat transfer. Furthermore, equipped with the latest inverter scroll compressor, QAHV can significantly increase the annual efficiency which fixed-speed systems cannot achieve. Let us explain more about the role of the twisted and spiral gas cooler. The three connected refrigerant pipes are wound around the twisted water pipe. Since the contact area between refrigerant and water is expanded, that allows the water pipe diameter to be larger. This can avoid scale adhesion, preventing efficiency drop. In addition, the expanded contact area maximizes heat transfer and contributes to enhanced efficiency. Due to this high efficiency, the downsized casing is realized, attracting customers who focus on smaller installation space. In case of high outlet water temperature, QAHV can achieve higher COP due to its refrigerant property. Let's take a look at an example. This is a case of the inlet water temperature of 17 degrees Celsius and the outlet water temperature of 65 degrees Celsius. As the diagram shows, when the delta T is 48, the COP of 3.88 can be achievable. Therefore, high outlet water temperature is a strong point of QAHV as higher COP can be realized. Next, let us show you QAHV's year-round hyperheating capacity in extreme climates. As you can see, QAHV is able to provide full heating capacity even at ambient temperatures of -3 degrees Celsius. Furthermore, the unit is operable and can supply 90 degrees Celsius of hot water in ambient temperatures as low as -25 degrees Celsius. The technology behind this is an injection circuit that provides an optimum amount of refrigerant to the system. The refrigerant is provided through a specially designed injection port of the compressor, ensuring stable operation even in low ambient temperatures. Lastly, QAHV can supply high-temperature hot water of up to 90 degrees Celsius. Such high outlet water temperature is attributed to the refrigerant property and Mitsubishi Electric's unique technologies. R744, the CO2 refrigerant, is able to conduct efficient heat exchange in a supercritical state. Since heat conductivity is high in such a state, high-temperature water can be supplied efficiently. Moreover, as we mentioned earlier, our technology includes compressor development, small gas cooler adoption, and refrigerant circuit control technology. Thanks to all these factors, hot water of 90 degrees Celsius can be provided successfully. Considering these aspects, QAHV's recommended application is hot water use for facilities where shower and water tap is equipped. QAHV can be promoted to various places, such as food processing factories, fitness gyms, hotels, restaurants, and so on. On the other hand, heated pools, floor heating, and space heating with radiators are not recommended applications. In such applications, CAHV will be more advantageous as it is good at maintaining and raising temperatures gradually. Especially in larger scale facilities, they must supply and retain a larger volume of hot water. In such cases, the combination of QAHV and CAHV can achieve greater energy savings. By combining QAHV and CAHV, you can take advantage of each strength. Therefore, we can propose extensive applications for our customers, utilizing both the strengths of CAHV and QAHV.